Hello, everyone. So our first speaker for this session will be David Koop, who will talk about notebook archaeology.
Thank you. Thank you for all coming to this last set of small sessions, JupyterCon. I know it's after lunch, so I appreciate you attending. And I do want to talk about this term I'm sort of calling notebook archaeology, but really digging into what an ipynb file, that notebook file format, tells us or maybe sometimes doesn't tell us. So let's start with what a notebook looks like in Jupyter Lab or Jupyter Notebook, right? What we see is a very small notebook, but doing some data analysis. We see things like markdown cells, right? Not only do we have the ability to put code in notebooks, but we have the ability to put text and that literate programming idea. But we also have code cells, right? So in this case, there's some Python code. And then over in the left margin, we have something called the execution count, right? This sort of increments when we execute code cells in Python. But beyond that, one of the cool features of the notebook is that we have output, and that output's not limited to things that appear on sort of textual command lines, right? We have output that's rich output like HTML, so a data frame shown as a table. We also have the ability to put standard output, numeric values, but also images, right? And this one's a slightly different output in that it's not really the output of the cell, right? A matplotlib figure sort of comes along on a side channel, if you will, a display data channel to show that image. So that's one view of a notebook. Another view is when you open that notebook in your favorite text editor, right? And looks a little bit different now, right? It's this JSON file format. Some of you may be familiar with that from other sorts of data format. It's a standard. And what we see in the notebook specifically is that there are these divisions into cells, which is a list of cells, very truncated in this case. Some metadata, that is a dictionary that includes information about the kernel. So in this case, the fact that I'm using Python through IPyKernel, and some language information. So in this case, Python 3.9. And then at the very bottom, and this could be in different orders, but there's information about the notebook format version. So in this case, version 4.5. Now, if we dig a little bit further into the cells, we see different types of cells, right? I had markdown cells and I had code cells. But between those cells, we have some common things. The cell type, right? Different for markdown and code, but also there's a raw cell type that can also be there. We also have an ID. So in this case, it's a UUID that was added somewhat recently into the file format, but it's a unique identifier for the cell. And then a metadata dictionary. In this case, they're both empty, but that can be populated with information, sometimes by extensions, sometimes by other things. And then the source. So for markdown, it's markdown markup. For the code cells, in my case, it's Python code. But the code cells contain a little bit more, right? They contain this execution count that we saw on the left-hand margin when you look at the notebook in Jupyter Lab or Jupyter Notebook. That's a number. And then outputs, which is a list. In this case, for this cell, it's empty. But in other cases, that contains a lot more information, right? It contains a list of dictionaries. So each entry is itself a different output. So for something that's just printing out a simple number, we have this data dictionary, contains MIME types as well as the values that are output in that type. Some execution count information that should usually match the execution count of the cell. And then metadata, again, can be associated with the output. And finally, the output type, which in this case is execute result. Now, things get a little more interesting when you look at a cell like the pandas table. So in this case, we actually have multiple representations of the data. So we have an HTML representation, that's what we saw in the notebook, but there's also a text representation, a plain text representation. And so depending on the front end, it can actually pick which representation it wants to display. So display that's not capable of showing HTML or a particular type of MIME type can choose a different MIME type potentially to display. But we can also have multiple outputs. So that last cell that had the matplotlib figure in it has the execute result, which is actually some text. And the reason I get this is because I execute my notebooks using a mode where I both show assignments and the final execution result of the cell. But in this case, it's sort of this text that shows information about the array that's storing the matplotlib axes. But it also just contains the display data in this case, which is an image, a PNG image that's encoded via base64 encoding, but can be read by JupyterLab and interpreted in that way. Right, so there's a lot that's hiding in these cells, a lot of information, including information about the outputs, which allow you to open a notebook and see sort of what was going on when you last visited that notebook. And there's one other type of output, a stream output. If you're printing things out, either via standard out or standard error, that also shows up there. So, to summarize what's there, notebook format version, metadata, and then a lot of information about the cells that are obviously the key components in a notebook, with particular data about metadata, the source, and the execution counts, and then output information. All right, so where do we go from here, right? What can we actually figure out based on these files? What sort of archaeology can we do on the notebook? What can we find from that information that's stored in the ipynb file format? So I'm looking at this from sort of a reproducibility viewpoint, right? So what I'm curious about is, if I have the code, can I rerun the code? Can I check that the results make sense? And can I do anything with these execution counts, right? And I'm going to spend some time trying to really dig into that question. So rerunning the past code, in this case, we're not that much different in notebooks than we are in scripts, right? You just have the code, you run that code in sort of a top-down fashion, and you hope that you get the right results. Doesn't always help, or doesn't always work, though, right? Sometimes you run across a file that's not found, right? I didn't transfer the file when I transferred the notebook. But if I fix that and I run it, I get the result that I had earlier, right, with the results filled in. And so sometimes you'll see notebooks where you sort of clear all the outputs. Sometimes it's done in teaching situations where you want students to execute the code and see what happens, not just see the results immediately. But we can also look at things like reproducing the past results. So the notebook usually comes with the outputs attached to it, right? They're in that ipynb format, and so when you open the notebook, you see what the results were when the notebook was last run. And so you might go through and try to run these code again. And one of the interesting things that can happen, if you have a sharp eye, right, you notice that figure in the bottom, it changed, right? So perhaps something changed about my data. I removed some of the data, or the data just was updated, right? And so now I can see there's a difference between the figure on the left and the figure on the right. And so this tells me I didn't reproduce my results, something changed, and I need to sort of dig into what might have happened there. A slightly different case is here when I sort of switch the order of the notebook, right? So when I run this notebook again and try to reproduce it, I get an error. But in this case, it's not due to the data not being there. It's due to the fact that I'm referencing a variable that's not defined yet, right? If I run things in a top-down order, the cell at the top and this next cell, right? And the reason here is that it looks like, right, this cell was actually executed after the two cells below it. Right? If you look at the numbering, that sort of clues us in that really the first cell was executed, then we jumped to the third cell, then the fourth cell, and then came back to the second cell. Or perhaps we moved that cell up, trying to show off the result higher up in the notebook. That's something you can do with cells, is move them around in the notebook. And so this numbering thing is kind of an interesting question of trying to figure out what somebody actually did when they were running the notebook initially when you go back to it 2 weeks later, 2 years later. So a question we might have in this archaeology sort of space is, can we infer the past events? Can we infer sort of the history of the ipynb sort of development, right? How code was developed, how things were added. And this sort of, if we look and zero in on the code specifically, because we have those execution counts, we can try to think of some way to do this. And so a slightly different example, but the exemplar notebook, right, again, is one that runs in top-down order. Don't have any issues. You can read the code from top to bottom, and that's something that Jupyter really encourages, right? It makes it clear to someone who's reading the notebook what is going on and puts things in the right order. But we don't always do that, especially as we're exploring data, right? And we end up in situations that are much more confusing. So in this case, we actually have two number 4 cells. Kind of odd, right? We have no 2 or 3 cells here. We just jump to number 4. And then we also have some things that are out of position like before, where we have 5, then followed by a 4, and then cell number 6. And so digging into this and trying to figure out what might have happened here is a little bit more difficult. And there's one other thing here. If you look at the code and try to understand it, the columns that are printed out in the cell before this one that references it don't seem to match up with the one that's being used in the query here. So we have the notebook. That's an artifact that we can look at, right? It doesn't tell us everything because it doesn't tell us about when cells are deleted, or maybe they were executed more than once, or maybe when a cell was moved, right? We do have another artifact that sometimes exists with notebooks. It doesn't always live with the notebook, though, but it's the session history coming from IPython. And it's basically a linear recording of all executed code. And if you were at the security talk earlier, you heard why this can be potentially hazardous if you put things like defining keys or access tokens or things like that there, because it might live on in this SQLite database. But the thing with the session history is there's not really a tie-in back to the notebook. It doesn't know which cells in the notebook were necessarily executed. So if we step through that example of that confusing notebook again, what we can do is we can look at the pandas code, right? We load the data, we examine the columns, we go ahead and load in the data, and the session history is keeping track of those same code executions. Okay, but now I might make a typo, right? And I don't do body mass G, I need body mass, so I go in and fix that typo. The session history is going to record both of those executions, right? So it records that number 5 was the typo version, number 6 was the one where I fixed it. Now what I might do is stop, right? Or give this to someone else, and they might open the notebook. That causes a new session, right? And that causes the numbers to start over again. So in this new session, I can go back. The numbers stay actually from the previous session, but in the new session, I can go back and start executing again. Cell 1 becomes 1, 2 executes again. Things look very much the same. But then I see these columns and I'm like, I don't like these columns. I want the new version of the data set, right? It's a slightly different version of this Penguins data set. And I go back to cell 2 and load that in, right? And then I go on and look at its columns. And then I get distracted and leave the tab open, and eventually the ipynb file gets saved, but I sort of go away, right? And that's actually how I ended up in this case with 2 4s and things out of order and missing numbers, right? But the session history together with the notebook kind of tells me what actually happened there. But it led to this confusion, right? With 2 number 4 cells, that's because of 2 sessions. Now I understand that. No 2 or 3 cells. Well, actually there were. I just executed those 2 cells sort of twice, once after I had edited that second cell. In the session history, there's also some confusion if I just look at that, because it doesn't necessarily map to the notebook structure. Right? What I have here is, are cells 2 and 4 related? Maybe, maybe not, right? I can't tell that they were actually edits to the same notebook cell. So, can we do something about this? Can we try to infer what might have happened if we can't sort of play back what actually happened, right? And so the question is, can we sort of build an algorithm? So again, we have the session information, new session created every time a notebook's opened, and a user may revisit the session, the same notebook in multiple sessions, right? You close a notebook, reopen it, you can certainly get into different sessions. The cells all have execution counts attached to them. Whenever a cell is executed, it gets a new execution count from the session. That starts at 1 for every new session. But old execution counts get preserved in the notebook in future sessions, right? That's why we can see these number 4s twice. But they're overwritten when the cell is re-executed. Okay? So this leads us to sort of introduce some new terminology, kind of looking at these gaps in execution counts, right? So if I look through all the numbers in my notebook, I can find those that just don't exist. So 2 and 3 don't exist, so I have this gap from 1 to 4. Subtract that, that's a gap of 3. A jump is obtained by looking at sort of the numbers that go together, so like 4 and 5, and look at the positional difference, right? So the gaps are the gaps in the execution count. The jumps are the jumps between the numbers that are sort of in consecutive cells then, or consecutive numbered cells. And so if you put those together, you can kind of characterize what's going on in the notebook through this tuple of gap jumps. So What we can do is grab some data. GitHub's a great source for this, right? They have lots of notebooks. We heard about that in the keynote on Wednesday. And they also have some session histories. Turns out people store their dot files in GitHub, and that includes .ipython directories, which includes some history.sqlite files, which could be a security issue. But for us, it allowed us to do some research on what's going on in the session histories if we assume they're linked to notebooks. And some of the findings, which are reported in this paper, are that cells are repeatedly executed. We see that in the session histories where the same code is executed multiple times or slight tweaks to it, right? People fixing typos, people changing data sets. The other thing is that we see that notebooks are revisited. So if you look at different sessions, what you'll see is the same code being repeated in often the same order, right? And that's a clue that somebody came back to a notebook later on and re-executed the same code. If we look at the notebooks, we can look at these gaps and jumps, looking at those execution counts, right? And what you see is there's basically the pattern you would expect. Most of the time, you see the consecutive numbering, 4, 5, 6, right? And the gaps get less frequent as you go. So 4 to 6 is more frequent than 4 to 7, which is more frequent than 4 to 245. The gap distribution is also monotonically decreasing. So most of the time, we have this sort of those consecutive cells are right next to each other positionally in the notebook. And so if we look at the counts there, what we can see is that the normal sort of going from the first cell to the next cell is where the numbers are consecutive, 3 to 4 on top of each other. That's the most common thing that exists in the notebook file. But if you look at the session histories, repeated execution is actually more common than any other sort of jump, like going to some other part of the cell or leaving gaps. So we can build this sort of heuristic algorithm based on these two principles to basically try to reconstruct what happened, right? So doing as much in order as possible, 3, 4, 5, 6, 7, and then repeating the final cell when we need to. It could be any cell, so we take the last cell as a possibility. All right, so let's get an example to try to make this hopefully a little clearer, right? If I have a bunch of execution counts that look like this, going from 13 to 20, I'm missing the numbers 14 through 19. And I'd sort of like to be able to figure out where they might fill in, what might have been executed in that case. And so what I can do is divide the remaining cells in between these numbers up based on those that are sort of too small, below 13 to 20. I can't re-execute those because the cell numbers are too small. And those that are larger, where I could have executed one of those cells and then came back and executed it again. Right? So if I think about using those places that are larger as places that I could sort of fill in, I could fill in the cells right after 13, as with 14, 15, 16. And I could then jump over those 7 and 8 cells and continue with 17, 18, and 19. And now I'm not quite at 20, so I'll actually repeat that last cell. Right? So this may be some sort of history of what might have happened as somebody was going through the notebook. Right? It's at least somewhat in line with the data and what we think might sort of have occurred. Now the question is, can you evaluate this? Is there any way to sort of test, like, does this make sense? And one way you can do that is look at sort of syntax and see if the code would have run. Doesn't mean there aren't notebooks out there that don't have the right syntax, have bugs and things like that. But if we assume they do, which is probably the majority case, what we can look for is cases where the cells are sort of out of order. That is, where a variable was used before it had been stored. Right? So a variable was assigned basically later on in the notebook, but it was somehow used before that. And so if that happens, we call it out of order. And so what we can think about is, if we just execute the cells in positional order, top down, what does that look like syntactically? Does it make sense? Or if we follow the numbers exactly, 1, 2, 3, 9, 7, like whatever the order is that the numbers tell us, what does that do in terms of out of order syntax? And then the inferred order is sort of what our algorithm does. And so what we found is, positional order works pretty well syntactically. And this kind of makes sense because people are going to write notebooks that tend to go in that top-down order, right? The execution count order doesn't work as well. There's a lot of out-of-order cases. And the inferred order is much worse than the positional order, right? Our algorithm doesn't do great, but it actually does cut down on, if we try to follow the numbers exactly, the execution counts, cuts down a lot on a bunch of those errors, right? About 13,000 or so of those. So positional order still works best syntactically, right? People think about their documents, their notebooks in this top-down format, and that makes sense. But it doesn't actually tell us what happened, right? If we really want to sort of trace back and see exactly what happened, that's still sort of missing from the history that we see, right? The notebook will run for somebody else most likely, but it wasn't necessarily how it was run in the past, and that can lead to issues with reproducibility. All right, so basically the notebook isn't storing this full sort of history of what's happened to it. It's full version history. So a question might be, can we improve future records in some way, right? So if archaeology is trying to deal with missing bones and things like that, how do we sort of improve things so that we can gather more information in the future and ensure better reproducibility? And so I'll suggest 3 techniques in this space. One is trying to improve the structure and execution of the notebook, right? Can we sort of connect things in a better manner? Maybe storing more metadata with the notebook, and then thinking about versioning. So in terms of improving structure and execution, this is something, I analyze a lot of data, and so I have df variables throughout my notebooks, and unfortunately I reassign them all the time, right? And so it's sometimes hard to figure out which df variable I'm referring to. And so one of the tools that we've developed, this data flow notebooks framework, is something that allows tracking of sort of the dependencies between the cells. So even though all of them are named df, we can sort of link back. And we can even put in things like tags so that you could explicitly refer to that df, that cell's output, rather than whatever one happens to be current in the state of the kernel. So some things that happen here are the cell's ID is sort of a persistent identifier. The outputs are named. There are references to the cell outputs, kind of define the dependencies between the cells, and that leads to a more reproducible execution order. And because of the tags, you can sort of link things in not while you're working, but be able to go back to a cell and say, okay, I want to reference this cell later on. Give it a tag, and then in the code, you can refer to that back. And then behind the scenes, what we want to store is persistent references to the actual data that was used in a cell's execution. So the sort of linkage so that it's preserved so that when you go back to the notebook later on, you can know exactly what was actually executed. If we look at the more metadata side of things, there are things that have been pointed out in other talks on reproducibility at this conference and in other locations. One of them is that missing packages or missing dependencies. One question is, why can't you inline some of that requirements.txt or other sorts of information in the ipynb file, right? I've seen some folks that actually print out the versions of different libraries at the top of their notebooks. That's one possibility there, but maybe we could do better and put that as part of the metadata of the notebook. Another possibility is that session history, right? IPython has a history magic. You can use it in the notebook. You could use that and sort of automatically store that with the notebook. So you have this pair of history and notebook information together. Potentially that leads to security concerns though. And then there was this cool lightning talk on Wednesday where somebody said you could embed your data in the ipynb format, and sure you can, right? There's actually a proof of concept to do that, this jup embed. He also said, don't do this, really don't do this. But thinking about it, if you want the ipynb format to sort of contain what you need to rerun your code and your experiments, right? That's maybe not the worst idea. All right, and then I'll finish up with a couple comments on versioning. There's the Git extension for Jupyter Lab. There's JupyText and other formats that try to think about how you can separate out the outputs from sort of the main code and literate part of the notebook. And then there's commercial solutions that have version histories that you've seen. There's also an interesting tool that I came across, sort of a research tool called Verdant. I think some of that was addressed at previous versions of JupyterCon as well. Not my tool, but kind of an interesting idea that maintains more detailed information about the history. Not just here's my IPython notebook and here's another version of it, but kind of thinking about what's actually going on, where cells added or where cells deleted, so a more semantic understanding. And so there's actually ways to view the previous versions and look at the history and search. So you get this sort of side panel that shows information about different versions, when they were constructed, but you can actually go back and do sort of diffs in the notebook that are a little more rich than you can just get from some other tools. Unfortunately, I don't think this installs with the current Jupyter lab. It's sort of a little dormant on GitHub. I think the researcher moved on to a permanent position elsewhere. And there's some interesting details about the history and some of the positional information that was used there, but I think this sort of line of looking at versioning is really quite interesting, and I'd like to see more work be done in this sort of vein of, if you really want to keep track of your history and you want it to mean something, going along this line, I think is a kind of a promising piece. And maybe we can go further, right? If you have this information, maybe we can learn from it, right? AI models are really being used a lot more. From metadata, we could try to, sort of figure out the types of environments you might want. With the version history, you might be able to sort of predict macros or operations that can be reused. So, the talk was, what does an IPynb file tell us or not tell us? You probably hopefully learned a little bit about that. But I also want you to think about, what could an IPynb file contain, right? If you think about the talk at the keynote and sort of promoting this file format as a way to store in an open structure, all this great scientific knowledge. Think about all of it that's out there, right? Can we improve it and have it store even more information? I'd like to acknowledge contributors. Obviously, the Jupyter team, all the open source development that was done on this was really cool to read the documentation. And with that, I may have a little time for some questions. Thank you.
Hi, great talk. Very much enjoy the term notebook archaeology, a fantastic term. With particular, I would say over the past 5 years, I've just seen an explosion of the amount of interactive outputs that come in the form of extensions, Jupyter widgets, etc. Doesn't seem like that is captured inside of here. And I'm curious whether you have any ideas around being able to capture some of that, because at least we're running some user studies with some users and they're spending 20, 30 minutes of their analysis session just playing with things inside of these widgets. And I'm curious what your kind of thoughts are on that.
Right, yeah, so the question was, I still have to repeat questions, right? The question was basically for interactive outputs, right? The notebook really doesn't capture that, right? If we don't think it's capturing other things, what about these interactivity? I believe there is some way to, I'm not an expert on sort of the widgets architecture, but I believe there is some way to sort of preserve some of the state in the widgets, and some widgets do that better than others in terms of allowing people to catch up or where they left off and other things like that. So that's one opportunity, but yeah, I think there's a lot more space there to think about what should be captured. Capturing everything is probably going to be way too much data, but there might be important pieces that are lost in the analysis that you're not getting without that interactive history. Yep.
Other questions?
Yeah, I'm curious what your thoughts are about the IPynb file being the source of truth versus the repo that has the IPynb file in it being the source of truth.
So this is a new schema for the notebook?
No, it's more, I'm curious your thought about the IPynb file being the source of truth versus the repository in which the IPynb file is hosted being the source of truth. Maybe we could come up with a repository scheme that make it reproducible.
Thank you. So the question was sort of talking about repositories storing the IPynb files along with other artifacts, right? So not trying to put everything in an IPynb file. And I think that's a recommended way of doing things, and that makes a lot of sense. I don't know that it always happens, though, and people like to ship around the IPynb file and sometimes bring along the other pieces or not. And so for more published solutions, I think having the repository is the right way to go. What might be nice is if you're in a more exploratory situation, sharing with collaborators and things like that, is maybe if it's in there, at least you don't lose that later on. But you're right that the best practice is to have a repository, I think.
Any other questions? Yes.
Yeah, interested in on my project that notebook as used as an article for academic journal, and by passing there is a technical review and peer review. And that I would like also to open some transparency about the peer review and the remark of the peer review, and give maybe this overview about what has been changed between this tape. And also that it will be used as we have in Word this possibility with the merge comment and to review that. But what have you some idea about this process of annotation in?
Yes. So the comment was about sort of peer review and the ability to sort of see changes and annotations, right? So if the notebook is being used in publishing, one of the things that often comes up in revisions for papers is it's nice to be able to see what's changed. And so, you can provide 2 different versions of notebooks, but then you have to provide the external tool like NBDime or something like that to show the differences in the notebooks. And annotations as well, I think, are an important part of that I think there are some extensions to deal with in tools like Jupyter Lab. But yeah, I'd like to see that as part of the record as well. I think that's very important. Thank you.
Thanks a lot for the talk.